Hi guys, this is Danielle again, and I have another calculus question to try to help you through today. In this question, we're being asked to use implicit differentiation. In this problem, we want to actually solve for dx dy. So in this case, we're going to be treating y as our independent variable and x as our dependent variable. So it's a little bit different than normal. And our equation is y secant x is equal to x tangent y. So our first step when we're using implicit differentiation is to take the derivative of both sides. And again, we're doing that in terms of y. So from here, you do need to use the product rule when we take the derivative of either of these sides. We do have two terms here. So to start with the left side, we have y secant x. So we'll go ahead and leave the y alone at first. And then we'll take that and multiply it by the derivative of secant x. So that's going to be secant tangent. And then we are taking the derivative with respect to y, so we do need to tack on our dx dy. And then now we can do the second part of our product rule. The y is just kind of over here by himself, so when we take the derivative of that y, it is going to just end up being 1. And we multiplied the derivative of that first term, that 1, by our second term, so that will just end up being secant x. So I am kind of putting together a couple steps here, so just in case you miss that again, the derivative of the y ends up just being a 1, and then that's multiplied by our second term here. So then this ends up being the product rule of this here. Now on our other side, we'll go ahead and do the same thing, starting with our x, which we'll leave alone, multiplied by the derivative of our second term, which is tangent y. That ends up being secant squared y. And in this case, we are doing the derivative in terms of y, so we don't need to tack on the dy here like we did with the dx dy over here. So that concludes our first part of the product rule. Now we're going to add on the second part of our product rule, in which case we do need to take the derivative of the x this time. So the derivative of x would just be 1. Then we do need to multiply by the dx dy. So that just ends up being dx dy multiplied by our second term. So again, just to recap, we have this term here. This is all the product rule with that term. And then over here, we did the product rule on the right side. So now what we want to do is we are still trying to solve for the dx dy. And we have this big term over here that has the dx dy. And we also have this term over here with dx dy. We want to go ahead and get those terms on the same side and get these other terms which do not have the dx dy on the same side. So we can go ahead and rewrite that then. I'm going to put my dx dy over here on the left. So then here I'm going to take this other dx dy term, I'm going to put it over here. And when I'm doing that, I am going to be subtracting this term from either side. So it's going to end up being minus and that's going to be equal to my first term that was over here, and then we're going to be taking this secant x and subtracting it from both sides as well. All right. Now that we have these two terms over here, both with our dx dy, we can go ahead and factor out that dx dy. And we end up with our two terms left over. And then we can go ahead and divide out that term, so that way our dx dy is alone. And there you go. Here is your final answer with dx dy by itself. So we've used implicit differentiation to solve for dx dy, and there you have it.